Some kind of way you done found yourself for the online tutoring of Mr. Whittington's. Is it Mr. or Mr.? Mr. Whit? How that man say that? Anyway, today's episode is on factories. Now I don't know what in the Sam here any of this means, but I hope you enjoy yourself, so get your ink pen and your pencil and get ready to learn about factories.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring. Today's tutorial is going to be about factoring a general strategy. That's right. We're going to have some options for you. So what's the game plan? Number one, you're going to look for your greatest common factor first. Always look for the greatest common factor. So you're going to look at the number of terms that you have, and you want to find out if any of these terms have something in common other than one. All right, so look for the GCF first. Then the second thing to keep in mind, if you have 4 terms, you're going to try to factor by grouping. All right, now that doesn't mean that you'll always be successful doing that, but generally if you have 4 terms and you're asked to factor, try factoring by grouping. All right, then the next thing you want to be able to do is be able to identify special binomials. Yeah, all right, things like difference of squares, sum of cubes, and finally, anytime they're asking you to factor, look at it as factoring completely. That's right. Read those directions of factor as though it says factor completely, because many times you'll be able to factor multiple times. Yeah, so you want to always try to factor it all the way down till it can't be factored anymore. So keep that in mind. All right. And finally, this A right here is for Anna. This is a shout out to one of my students at Houston Community College. What's up, Anna? What's up? All right, let's go ahead and look at some examples. In problem number 1, we have 2x to the 4th power plus 8x cubed plus 6x squared. And we're always going to begin by looking for the greatest common factor first. These 3 terms have the GCF 2x squared, all right? So if I look at my coefficients, 2, 8, and 6, they all can be divided by 2. So we'll definitely factor out a 2. As far as that common variable that they have in common, that variable x, you always take the lowest exponent on your variable when you're factoring out the GCF. So that's why I have my x to the 2nd power here. From there, you're going to factor this term out. And remember, factoring is associated with division. So it's as though each term will be divided by the 2x squared, and then I'll write that result inside of this parentheses here. So dividing 2x to the 4th power by 2x squared, 2 goes into itself once, and x to the 4th power divided by x to the 2nd power will leave you with x squared. All right. Remember, when dividing like bases, you subtract the exponents. Then 2 goes into 8 4 times. Yeah, just like that. And then x cubed divided by x squared will leave me with x to the 1st power. Yeah, just like that. Then 2 goes into 6 3 times. It sure does. And then x squared divided by x squared is just 1. So that's going to complete that factoring step right there. But notice inside the parentheses, you have a quadratic trinomial. Yeah, you do. So this is one of the easier ones because my coefficient on that first term inside the parentheses is 1. I'm only going to be looking for 2 factors of 3 that will add to give me 4. Well, that's 3 and 1. So that means that I'll be bringing down that 2x squared. All right, opening up 2 sets of parentheses here. I know that my variable in play is the variable x. So I'll have that as the first term in each one of those binomials. And then I'll have my factors of 3, which is 3 and 1, because they add to give me 4. And the sign of the middle term of that trinomial will always be the sign of that largest factor. So that means that the 3 has to be a positive sign. And since I'm trying to add to get 4, the 1 needs to be positive as well. So that's the answer. Oh, you don't believe me because I haven't put a red box around it. So there you go. Here's your red box. There you go. Red box in it. Done, ladies and gentlemen. So we always begin with the GCF, the greatest common factor, first, and then we always factor completely, which means that you look at your result to see if you can continue to factor. And in this case, we could because we had that quadratic trinomial. And we had to factor that. Yeah, so we factor that, and there's your answer right there. So if you need any help factoring those type of quadratic trinomials, check this video out right here. Click on that link and check out our video, Factoring Quadratic Trinomials, Part 1. All right, let's move on to the next problem. All right, moving on to problem number 2. We have x cubed minus 5x squared minus 25x plus 125. In this problem, we have 4 terms. Yeah, 4 terms. So what does that mean to us? If we have 4 terms, that means that we will most likely need to use factoring by grouping. So that's what we'll do. I'll go ahead and group the first 2 terms together. This x cubed minus 5x squared, you'll always put a plus sign between the terms, and so we'll have negative 25x plus 125. So notice how I put the sign of my third term inside of that second group. Always do that. Yeah. Out of the first group, you're going to factor out your GCF, and these 2 terms have x squared in common. Yeah, that's a 2. It's an ugly 2. Yeah, it's bothering me too. Alright, let me go ahead and fix that 2 because it's just too ugly to stay. There you go. That's a better 2. Barely better. So we'll factor out x squared now, and that'll leave me with x minus 5. And then out of the second group, we can factor out a negative 25. How about that? Alright. So factoring out the negative 25, factoring is division, so it's like dividing by a negative, so that's going to also change the signs here. So we'll end up with x minus 5 inside of those parentheses. When using the method of factoring by grouping, you want those binomials to be identical, and they are. They're the same. So that means that out of these 2 terms that remains, they have a GCF of x minus 5, and what's left over goes inside the second set of parentheses, which is x squared minus 25. Alright, so we look at our result to see if we can continue to factor. I know inside the first set of parentheses I just have x minus 5, and those are unlike terms and you can't do anything with that. However, this is a difference of 2 squares. This is a difference of squares. We can factor that. All right, and then our next step here, we'll go ahead and bring down that x minus 5. You're going to open up 2 sets of parentheses, and the factorization of x squared minus 25 is going to be x plus 5 times x minus 5. All right, notice how we have 2 x minus 5s. So you can't leave your answer like that, because notice how you have that x minus 5 here and you have an x minus 5 there. This would not be considered simplified, and you gotta simplify your result. So we're gonna write our answer as x minus 5 squared times x plus 5, and this is gonna be our answer right here. Yeah, let's go ahead and put a box around that. Boxing it up just for you. All right, so that's your answer for that problem. That's problem number 2. All right, we have problem number 3, ladies and gentlemen. This is 7m to the 4th power minus 7. 7m to the 4th power minus 7. And here we have 2 terms. This is a binomial. All right, remember that terms are separated by plus or minus signs. So in this situation here, we always begin by looking for a GCF, the greatest common factor. And in this case, our greatest common factor is 7. So I'll be factoring out a 7 here. That'll leave me with m to the 4th power minus 1, just like that. Remember, you can always check your current step by multiplying it out to see if it'll give you the previous step. So 7 times m to the 4th power is 7m to the 4th power, and 7 times negative 1 is negative 7. So we're good. We're good so far. Now, anytime you have an even exponent, yeah, that's a perfect square, always. So the m to the 4th power being a perfect square and 1 being practically a perfect anything, this is a difference of 2 squares. It is. So that means we can continue to factor. So let's go ahead and bring down that GCF of 7. Open up 2 sets of parentheses here. The square root of m to the 4th power is m squared. All right. The square root of 1 is 1. All right. All right, you'll then have a plus and a minus sign added to the picture. And from here, we want to be able to identify the types of binomials we now have. This first set of parentheses has m squared plus 1. Well, that, ladies and gentlemen, is a sum of squares. And a sum of squares is not factorable. All right. However, a difference of squares is what you have in that last set of parentheses. That is factorable. So we're going to bring down that GCF of 7 as well as that sum of squares. So you cannot factor a sum of squares. So anytime you have something in the form of a squared plus b squared, a perfect square plus a perfect square, you can't factor it. Don't even try. So we're going to go ahead and bring down 2 sets of parentheses because we will be factoring that difference of squares there. So the square root of m squared is m. And the square root of 1 is 1, like so. And then I'll have a plus and then a minus sign. All right, so this is my answer right here. Yeah, 7 times m squared plus 1 times m plus 1 times m minus 1. I know I'm done, ladies and gentlemen, because I cannot factor a sum of squares. I can't do it. So this is the answer. Yeah, I'm boxing it up right now. There you go. Done and done, ladies and gentlemen. That's problem number 3. Number 4 is coming up. All right, in problem number 4, we have 90c squared minus 51cd minus 105d squared. Yeah, we have a trinomial. We have 3 terms. However, the numbers are huge. Okay, the numbers are really big. And second, we just need to start our general strategy, which means we need to begin by finding the GCF, looking for the greatest common factor. Now, you may not be familiar with the numbers that you have in front of you, but you should always use your divisibility rules to assist you in the process. So knowing that all the numbers are not even, all the numbers don't end in 0 or 5, my other option is to add the digits. All right, let's see what happens here. 9 plus 0 is 9. Okay. 5 plus 1 is 6. 1 plus 0 plus 5 is also 6. Well, what does that tell me? If I have sums that are multiples of 3, then that means that the original number can be divided by 3. Okay, so that's helpful. So that means that I can factor out the GCF 3. Yeah, 3 goes evenly in all 3 of these numbers, ladies and gentlemen. So therefore, 3 goes into 90 30 times. I'll be bringing down c squared here, and 3 goes into negative 51, negative 17 times, bring down that c and that d, okay? And then 3 goes into negative 105, negative 35 times. It sure does. Just like that. All right, ladies and gentlemen, we have just factored out the GCF, and now we most likely will be able to factor out that quadratic trinomial. Yeah, I'm thinking that we can. So we're going to do the following. We're going to be breaking down the 30 and the 35 into their prime factors. I know that 30 is made up of 2 times 3 times 5. I know that 35 is made up into 5 times 7. Okay, so I believe I'm going to begin by multiplying the 5 times the 5 together. That gives me 25. All right. Yeah, 25. So what's left over is 2 times 3 times 7, which is 42. And 42 minus 25, yeah, let me write that down for you. 42 minus 25, that gives you 17. Bingo, that's what I needed. Let's go ahead and bring down the GCF of 3, open up 2 sets of parentheses. We'll need our variable c, all right, we'll need our variable d, and I'll also be using 42 and 25, like so. The 42 needs to be the sign of the middle term, which is negative, all right? And because we're subtracting to get 17, we need the 25 to be positive. All right, now, at this step, we're going to divide by that leading coefficient of 30. Ladies and gentlemen, I'm using an AC method, all right, of factoring, and you can find that in our video, Factoring Quadratic Trinomials, Part 3. The link is right here. All right, so check that out, especially if you need to break it down because the numbers are big, like we have big numbers here. All right, from here, we're going to be simplifying the 42 30ths and the 25 30ths. All right, so at this point, simplify. All right, so the 42 and the 30 can be reduced by 6. So I have 3 times c minus 7/5 d, and then in that last set of parentheses, the 25 and the 30 can be reduced by 5. So that gives me c plus 5/6 d, like so. Any remaining denominator will go in front of the variable in that first term. So you'll have 3 times, this 5 goes in front of the c, so that'll be 5c minus 7d times 6c plus 5d, and done. That's it. That's the answer. Just like that. Boxing it up, ladies and gentlemen. Red boxing it. All right, that was problem number 4. Let's move on to our next problem. All right, for problem number 5, we have 4a squared pq plus 4ab pq minus 120b squared pq. First of all, ladies and gentlemen, I would like to thank Leo because Leo helped me correct a previous upload of this problem because it was wrong and he found my mistake. So thank you for keeping me honest, Leo. We really appreciate your help. Thanks a lot. So anytime we're approached with the problems and we're asked to factor, we're looking for the GCF first. That's right, the greatest common factor. And in this problem, our greatest common factor is 4PQ. So I'm going to factor out 4PQ first. That's going to leave me with a squared plus AB minus 30b squared. All right, so once again, you always begin by factoring out your GCF first, always. From here, we have a quadratic trinomial inside of the parentheses. So you're going to bring down that GCF of 4PQ. I'm going to open up two sets of parentheses, and since this is one of your easier forms of your quadratic trinomials, all you'll need to do is find two factors of 30 that will subtract to give you 1. Well, if you think about your factors of 30, you should know that 5 times 6 is 30, and if you were to subtract those two factors, you would end up with 1. So I know I'll need an A for the first term, and I'll need a B for the second term, and we'll plug in those factors that we talked about, that 6 and that 5. Your largest factor is always going to be the sign of your middle term, so the 6 needs to be a positive, and since I need to subtract to get a positive 1AB, the 5 needs to be a negative. All right, notice that you cannot factor anything out of these remaining factors. All right, so that means that this is your answer. So let's go ahead and box it up. Red boxing it. You got it, ladies and gentlemen. Once again, I appreciate Leo's help in keeping me honest in problem number 5. Let's move on to our next problem. Problem number 6. We have 9x cubed plus 12x squared minus 45x. All right. Well, you're going to look for a GCF first, right? So your GCF for these three terms is going to be 3x. All right. Then factoring out the GCF, you'll end up with 3x squared plus 4x minus 15. Okay. From here, we can multiply the first and the last terms together. That gives us 45. And you'll be looking for two factors of 45 that will subtract to give you 4. Well, wouldn't that be 9 and 5? I think it would. Yes, it will be. So that means we'll go ahead and bring down that GCF of 3x, open up two sets of parentheses here. So I'll have my variable x, I'll be using 9 and 5. I know that the 9 needs to be the sign of the middle term, so it has to be a positive value, and the 5 needs to be negative in order for those two to subtract to give me 4. From there, because I had a leading coefficient of 3, we're going to divide both of these numbers by 3 now. Okay, so dividing both of these numbers by 3 will then simplify to end up with 3x times x plus 3, and then any remaining denominators will go in front of your variable x to give you 3x minus 5. You need a refresher on this factorization process. Check out our video, Factoring Quadratic Trinomials Part 2. I go over plenty of problems like this, all right? And this completes our problem. We're done. It's completely factored now. Can't do anything else with that. Got a red box around my answer. And I'm moving on to problem number 7. All right. Okay, here we go. We have problem number 7 now. We have 48k to the 4th power minus 243. This is a binomial. We have two terms. Terms are separated by plus or minus signs. And I know that these two terms have 3 in common. Yeah, they have 3 in common. So we're going to be able to factor out 3. That leaves me with the following result. I'll have 16k to the 4th power minus 81. All right. Now, what I have left inside the parentheses is a difference of 2 squares. Because the 16 is a perfect square, our variable has an even exponent, which makes it a perfect square, and 81 is definitely a perfect square. 9 times 9. So let's go ahead and bring down that GCF of 3, open up two sets of parentheses here, and with that we will do the following. We will take the square root of the first term, which gives me 4k squared. All right, the square root of 81 is 9. All right, and then I like to lead with a positive and finish up with a negative because I'm an optimist. Yeah. The first set of parentheses has a sum of squares. You cannot factor this. You cannot factor this. You cannot factor this. You cannot factor this. So since you can't factor this, we'll be looking at this set of parentheses here, which is a difference of squares. So you can factor that. So go ahead and bring down the 3, the sum of squares, which you cannot factor. Did I say that already? And then go ahead and open up 2 sets of parentheses for that difference of squares right there. The square root of 4k squared is 2k. There you go. And then the square root of 9, it's 3. It's 3. So then you'll have a plus and a minus, and that k is jacked up. That's a little better. And then this is your answer, and done. There you go. There you go. Boxed it up and done. That was problem number 7. All right, let's move on to problem number 8. In problem number 8, we have 8x to the 4th power minus 1000x. We always begin by looking for the GCF, and in this problem, we have a GCF of 8x. All right. So factoring out 8x, that leaves me with x cubed minus 125. Just like that. Then this binomial that we have before us is a difference of cubes. All right. Yeah, the link is right here. Difference of cubes. We're going to factor that out. So I'll start by bringing down that GCF of 8x, opening up 2 sets of parentheses here, and the cube root of x cubed is x. The cube root of 125 is 5, so I'll have a minus 5 here as part of the factorization pattern here, okay? And then I'm supposed to square the first term plus the product of x and 5, which is 5x, plus 5 squared, which is 25. And this is the answer. That's it. Anytime you factor a difference of cubes or a sum of cubes, the trinomial that remains is prime. You can't factor it. This is our answer. Done. That was problem number 8. In number 9, we have x squared minus y squared minus 4. Yeah, there's quite a few things going on here, to the eyes, that is. The x squared minus y squared is a difference of squares. And the y squared minus 4, if you were to put that in parentheses, that would be a difference of squares. And if you were to put, let's say, the x squared and the negative 4 together, that would also be a difference of squares. But any attempt to do any of that is not going to put us in a situation where we can factor the entire expression. You can only factor a portion of the expression, and then that portion won't have anything that we will be able to do with the rest of it. So this is prime. It's prime. You cannot factor this, ladies and gentlemen, okay? There's nothing you can do that will make this factorable. So number 9 is just prime. You can't do anything. It is just messing with your eyes here. That's all it's doing. You can't do anything with it. Oh, okay, you need to see an example. Let me show you why. We had the x squared minus y squared minus the 4. Let's say I just take the x squared minus y squared minus the 4 here and factor that. That's going to give me x plus y times x minus y minus 4. This isn't a perfect square, so it's not as though I can take this perfect square minus that perfect square and factor it using difference of squares. There isn't anything I can do, and any combination of those original terms that gave you a difference of squares would still generate our answer, which is prime. It cannot be factored. Can't factor that, ladies and gentlemen. That's problem number 9. Alright, so I promise you in our next problem, we will be able to factor it. Let's check it out. Alright, so we have problem number 10. With 10, we have 9 minus a squared plus 2ab minus b squared. Well, you do have 4 terms, all right? But if you were to group the first 2 terms together and then group the last 2 terms, you could factor out a b out of the second group, but they're not going to match up. Any attempt to factor by grouping here is not going to work. It's going to be jacked up. But I did promise you that this was not going to be prime, right? So that means that sometimes you'll be able to think outside of the box and do the following. We'll go ahead and bring down the 9, and then I'm going to factor out a negative from the remaining terms. So factoring out a negative, I have a squared minus 2ab plus b squared, like so. Well, this is a perfect square trinomial. All right, so that means that factoring that, you'll end up with a minus b squared, okay? So I currently have a perfect square minus a perfect square. All right, and at the beginning I shouted out Anna. Yeah, the first page had last page has na. What's up, Anna? So then, continuing on, using the factoring pattern for a difference of squares, I'm going to open up some brackets here, okay? And I'm going to say that the square root of 9 is 3, because it is. And then the square root of our last term is going to be a minus b. So I'll have a minus b here, all right? Like so. I'll need a positive and I'll need a negative. Okay, so that's the factoring those difference of squares there. But then I can combine this and say that the first group will just give me 3 plus a minus b. We're going to distribute. I got my arrows popping. Okay, so I have 3 minus a plus b, and this is the answer, ladies and gentlemen. Done and done. There you have it. I'm boxing this up. Just like that. And that is problem number 10. And ladies and gentlemen, that is our last problem for a general strategy for factoring. You got it. Hopefully this helped you out tremendously. As always, please go ahead and rate, comment, and subscribe. And if you're able, please donate. That helps us bring you more free math tutorials from me, Mr. Witt, and Fort Bend Tutoring. Peace.
Factoring. This includes topics such as GCF, that's the greatest common factor, like Obama. The difference of squares. Quadratic trinomials. Oh Lord, that's when the pig is sick on all 4 sides. The sum of cubes. That sounds like one of them games they play. Difference of cubes. Oh, that's just ignorant. AC method. Yes, honey, because you got to have your air conditioning in Texas. And factoring by grouping.